So here is our question.
Draw a straight line.
Oh.
How do you find the slope of a point on a curve?
Draw a straight line.
No, you do use a derivative.
That is correct. In order to find the slope on a curve at one certain point, what you are doing is finding its derivative and finding that value. And today, you are going to be learning to do just that. And not in the beginning of calculus, long, long way to do it type way. We're taking the shortcuts right from the beginning. Because that is how we roll in AP Physics.
Take a moment to give Katie a round of applause for finishing her water bottle.
Way to go, Katie.
Thanks.
No, this class is like basically our cup class.
Nice.
Which calculus?
BC.
No, they told me I was going to be in BC and then they put me in AB.
The first thing you need to write in your notes is the title of today. And that title is Derivatives.
How do you spell
D-E-R-I-V-A-T. I-V-E.
I have to look at my calculator.
Can I share an opinion?
Sure.
Really, really, really miss dad jokes.
Oh, the dad jokes.
You did dad jokes?
I forgot about those.
They were the best.
I can start those again.
Please. Was it
Sure.
because you were a new dad or something?
Yeah.
Yeah, he was practicing and then it was...
Oh, I see. Now it's okay because he still is a dad.
That's true.
But I missed that. Actually, it was
Oh, they'll probably be the same jokes, so don't worry.
Oh, yes. Repeat them as many times. I will still laugh. I have a dad joke sense of humor.
Do you remember?
D-E-R-I-V-A-T-I-V-E.
Rafa, do you remember October Wednesday?
No, what was that?
That was going to be the name.
Oh yeah, the name of the baby. I can't believe that
It was because it was like October Wednesday, October like 38th or something like that.
Right.
October Wednesday.
38.
That would have been a winner.
Well, he said if he was born on October 38th, he would name it October Wednesday.
So, the main thing you got to write down to start this is that a derivative is the slope of a function at a certain point. A derivative is the slope of a function at a certain point. The slope of a function at a certain point. So, you want to learn how to do derivatives?
Yes, sir.
This is how you do them.
Ooh, fun.
Think about,
Really doesn't look bad.
yeah, go ahead, write that down. Take 30 seconds. See if you can make logical sense out of that.
What's D? Like diameter?
Oh, I'll tell you later. See if you can figure it out, though.
Pretty sure we did this. Then you just take the first number times the exponent and subtract the exponent or something like
Yep.
Ah.
What class was that?
that. Freak out.
Nice. So what is this saying in like real world terms and not fancy math letter terms?
I don't even know what D is.
So D means you're taking the derivative with respect to x. So in every derivative, you have to have a variable that you're taking it with respect to. And in this case, it's x. Every other letter that would be here, every other letter that is not x in this equation, you're treating as a constant. You don't know what any of that means yet, don't worry. But basically, this is a special letter. That's what you have to take away from that. So, the derivative with respect to x of that is equal to this.
So usually we'll be given D and N and we solve for x. So we can
Uh,
How are you overthinking?
kind of. We'll go through some examples, and this is going to be crystal clear, I guarantee. So all this is saying is if you have a function x to the nth power, doesn't matter what number this is, to take its derivative, you pull out the exponent and put it in front, and then you subtract 1 from that exponent.
That's simple.
That's all there is to it. So, if I want to take the derivative of x cubed, what is that derivative going to be?
3,
X
2,
to
1,
the second.
3x squared. Because the 3 goes in front, and then we subtract 1 from the exponent,
Ooh.
and there you go.
Yeah, but then
The next one is 20x.
Then it gets all
cubed.
complicated with the fraction.
Yeah. So what was this one, Potter?
20x cubed.
20x cubed.
Next one is 1.
0.
Now, how do you know this is 1?
This is 0
It's a
exponent.
constant.
That's right. Because this is like saying x to the 1. So, if this is x to the 1, then the 1 comes out in front. 1 minus 0 is
1.
1. So,
Which is equal to 1.
because anything to the 0 is equal to 1. How about this one?
0.
Well, how do you know that?
There's no x.
No x.
Very good.
Yeah, Potter. You out here. Yeah.
What would the derivative of this be?
Is there an
Well,
undefined?
so-
Is there ever going to be an undefined derivative?
12.
No.
Okay. That makes it simple at least.
Right, Steve.
Gotta be some fractions.
Oh. Okay. Oh.
Oh boy. I understand. It wasn't.
We need a y for it to
What's the derivative of this?
0.
2x plus.
How do you know?
6.
Because if you're the special character you're looking for is y, because there's none within the
Whoa.
parentheses, it would be 0 because there's none to replace it with.
Exactly. So it doesn't matter how complicated this all looks. The only letter that you're taking the derivative with respect to is whatever's down here. Now there are a couple different ways of writing this part of your equation. And I'll just point those out real quick. And then we'll finish with the last third of the notes.
We're already halfway.
Oh, we're past halfway.
2/3.
Yeah.
Boy.
So, you know what this means.
Yeah.
If you're going to take the derivative of something like this, it would be the exact same thing as saying that.
Oh, okay.
The derivative of y with respect to x, because the x is over here, the y is the actual entire function. Another way of writing that is f prime x. So you're taking the derivative of the entire function y with respect to that special letter x, and that's how you would write that down. An easier way of writing this, if all those letters together confuses you, you could go the derivative with respect to x of your function y. Now let's say you take the derivative of one number and you get the answer, and then you want to take the derivative of that one too. Then this would just be f double prime. And if you want to take the triple derivative, it would be f triple prime. So I just kind of want to make you aware of that notation. Generally, you'll just be dealing with things that look like that. If you can follow that, you're in good shape. Questions so far? Cool. Well, let's finish the notes then. What's the derivative of that? It will just be 5. This is something called the constant multiple rule. If you want to really get into why this turns out to be 5, you have to apply something known as the product rule, which we'll get to tomorrow, I think. But if you just have a number by an x, then the answer is just whatever your constant is. So as you know, and this might look a little bit more confusing. What about this? What would the answer to this be? Yeah, it's just y. Because the only number that you're treating as a variable, the only number you're taking the derivative with respect to, is this right here. So anything that's not that, you treat as a constant. You treated 5 as a constant here, you're treating y as a constant there. How about this one? Oh, whoops. Yep, you're right.
Thank you.
The derivative of that function.
8x plus 4.
Yeah. Because 2 times 4 is 8. We got to subtract 1 from the exponent. And so that's where the 8x comes from. Here, the 4 comes out in front. We put a 3 up there then. And that's where the 4x cubed comes from. What's the derivative of that?
X is minus 2.
Very good. For the same rules that we just discussed. And just a couple little special things I got to show you. And then you guys can go ahead and take off to do the homework. You ready for this one? I don't know if you're ready for this one.
Some fractions in the exponent. Are you gonna do that there?
Derivative of the negative exponent.
Probably
That
gonna
would
do
be
some
fun.
fraction exponent.
That actually would be fun.
Or negative exponent.
That's what I do in my free time.
Oh, constant?
Okay.
So that's your function. What's your derivative? Any thoughts?
Hold on.
No. You got to think real hard for this one.
IN1.
That's e to the x minus 1.
Good guess.
Natural 1.
It would just be e.
You know that's
What?
That'll happen.
Anytime you're dealing with e to the x for a derivative, it just stays the same.
Can we do one of the alphabets with actual numbers?
No.
Because I guess
Just a sec. I'll do one more of these, and then we can toss up something like that. Sure.
I'm a little scared.
What's the answer to this? Placido.
39 e to the x 4x. Or would it be 39x?
You are correct. 39 e to the x plus 4x. Because whether there's a number that goes with it or not, when you take the derivative and you've got that e to the x function there, everything just remains the same after the derivative has been taken. Questions on any of this? All right, Sarah, what did you want to do?
So instead of having the normal form, because you were saying that with the primes, can we do a prime with actual number? Find a prime?
Yeah, sure.
Or am I just be out?
I mean, it would be, if we're doing a prime like an actual number, maybe it would be something like if f of x is equal to 3x to the fourth minus 2, then what's f prime x? That would be the way that you would write that.
Would just be the
Oh, so the difference.
12x to the third. It would just be 12x to the third.
So now here's where this all really comes together, and this is how, boy, you guys are going to have plenty of time to get the homework done. Good for you. Here's where this all needs to make sense, because it's very tempting to get confident with this stuff.
And then make mistakes.
That too. I was going to say, it's really easy to get confident and then just not really know what you're doing while you're doing it, because it's so easy. You know, you guys have this down already. So here's my question to you then. Let's say I put the number 4 in here. What's 12 times 4 cubed? Can someone tell me?
4 cubed would be 16
12
times
times
12. That would be 200 and
64.
768.
oh, why did I get 16?
640, 600,
768.
768.
something like that.
So what does that number mean? It's the result of a derivative, but what does that have to do with anything?
That's a distance.
You're plugging in 4 to the function.
That's true.
That's the
So
Wait, so is
That's
that
the
is the
slope.
derivative the second point that we're supposed to use to find the slope? So like how do we have the first point then would that be the point where we still keep it aligned?
yeah, what you both said. Let's say
So
this
the point that
function
you
looks
have-
like this. I don't know what it looks like, but it is an even function, so maybe it does look like that. And when I put the number 4 in, see that 4 is the x value on your x-axis. So what that means is that you're finding the slope of the tangent line at this location. So 768 would be the slope of your tangent line at x equals 4. That's what this actually means.
So 768 is the slope.
Yes, at this point.
So how do you write the entire function?
Well, just like that.
But, I mean, if you have the slope, how do you get
That's okay.
okay.
So that's what this all means. And to just put it a little bit more simply, let's say you're doing let's say it's y equals x squared, and you want to take the derivative of x squared. Y prime would be 2x. So if that's the same function as this one, and I want to figure out what the slope is at, say, 2, I have to plug a 2 in here. So your slope would be 4 then.
Now we can solve the question from yesterday.
Yeah, exactly.
So it's going to be like in that scenario it's the same when you plug it into either one. There's going to be ones where the
Oh, right.
prime is different from the
That just happens to be the case in
Right.
this. That's not usually going to happen.
because I know it there it's like 2 off because it's 766.
Yep.
But, okay.
So, that's all there are to derivatives. Here's your homework. I have a feeling you'll get this done with time to spare.
Wait, I got this time spare.